Check, check. Check, check, check. The beat's not coming through for some reason. Not sure what could have changed. Well, this is really weird. Hmm. Hmm. Oh, I wonder if this got messed up. Um, why isn't it asking me like the source? Like it's not asking me the like what device you want to play it from. It's just playing it, which I don't know where. I don't understand why it's not asking me for a output to play it through. Okay, there we go. All right. So I'm gonna show you. Actually, hold on. Let me turn this down a little bit more. So this is what I've been working on. I'm making a multi-band bit crusher, and I think I'm gonna add some kind of other weirdness to it to make it like a very destroyer sound kind of sound design project. So I can show you right now. I'm gonna get rid of this. That was just a test to make sure it was working. I'll show you how the multi-band part works so far. So let's build it. I made a multi-band class and put it in the VS Code DSP folder. It just splits your signal into 4 bands using the 3 Linkwitz-Riley filters from the JUCE DSP module. It's pretty simple. All right, so that's this one. Plug in Doctor. Okay, so right now we've got, it looks just like a regular, it's just a dry input, but we can turn the bands on and off. So if I turn band 4 off, or actually do I have to, let's see, do I have to do this? Or I might have changed something, let me see. So let's go back to plugin processor and yeah, okay, so I gotta get rid of this real quick and do this. So in the process block, I'm just deciding whether to do the oversample block or the normal processing, and I split them into 2 different methods and handled the oversampling logic in the oversample one. So let's try this real quick so I can show you the multiband part. The multiband's not perfect. I'm not sure what the issue is, but there's a little bit of discrepancy in the high end, like it does weird stuff. I'll show you. Yeah, okay. So you got to turn these mixes down for the moment. And this is the signal passing through the multiband separator thing with no other logic. So you can turn the high band off, the third band, the second, or the first. And then it's going to be easy to add a solo logic to this so you could solo each band. But each band also has a cutoff. So if we take band 1 off and then we move the cutoff of it, you see it goes all the way over there. And we do the same thing for 2. And there's 3. And then 3 also works for the top. So you can see it does some weird stuff when the high end cutoff approaches another cutoff. But I think it's good enough. It ain't much, but it's honest work. So yeah. The way it works is sample by sample. So if we go into, where is it, the multiband processor, it's processing it sample by sample, and you can always grab which band you need. So what I'm doing is in the process block, I am saying right here, yeah, so I'm looping through sample by sample, and I am telling the multiband, no, it's not linear phase, because I think the Linkwitz-Riley filters are IR filters. Hey, what's up, Blaze? Yeah, so you tell it to process the multiband, and then you can create some variables that each represent each band, and then you can do what you want with the band. So what I was gonna do is, let's see. Yeah, now we can, I think, we can get rid of that, and we can say, let's see. I've got an instance of the Bit Crusher. Yeah, should be good for vocals. I was kind of I mean, I think it would be good for anything, but I was kind of testing it with drums first. We're gonna also pass it through a we're gonna make a like a Car Plus Strong string model, because I think it can make it sound really interesting. But what I'm also thinking is that we have to have 4 instances of the the DSP that's going to apply to each band. So 1, 2, and 3, and 4. Let's go back into the the Bit Crusher real quick, and we'll just say, I don't think it's bad. It's probably pretty decent because I haven't even noticed. Usually you'll notice, and it's in debug mode, so that's also good. I'm gonna go back and do this input times 2 so that we know that the Bit Crusher is doing something. And let's go to the plugin processor. Since I added 3 more of the instances, we'll have to go add in the logic. So 2, 3, 4. And let's see, we're gonna have to grab those and put them in the oversampling part. So right here. And that should be good for now. We're gonna also have to make parameters for each one, which I'm guessing this plugin is gonna have a bunch of parameters. So what I'm thinking is we do I just do let's see, crusher1 dot process sample, the input, which is that, and then channel. Yeah, this is fine because the Bit Crusher is gonna have a mix knob, so I don't think we have to worry about the Bit Crusher always being on because you can turn the mix down. And what I'm thinking is when the mix is down, we can bypass the module so that it doesn't use up a bunch of CPU. Streamlabs desktop. All right, let's see here. Okay, yeah, that's working. So each one is multiplied by 2. Okay, so that works. Oh, you know what we could do is have them multiply by different amounts so that we can be 100% sure that it's working. So let's do something dumb right here. So we'll say void set mult. It takes in float new mult. And we'll say float mult is equal to, I don't know, 1.5. Do that here. Then we'll do that is equal to that. That should be good enough, right? And then we go into the plugin processor and we'll say, we could do this in, yeah, we'll do this in prepare. So we'll just say Crusher 1 set mult. We'll do the same thing for each. So that they are different amounts. So 1.5, 2, and 2.5. So now they should look like some kind of like line of hills going up. Yeah, I think it's going to be a lot of parameters. Might have to figure out a way to put all of them on the screen without looking weird, and also going to have to come up with some kind of UI that gives the user some kind of visual representation of moving the cutoff, kind of like you know, most of the time a multi-band plugin will have like squares for each band, and then when you move the cutoff, it moves like the line in the middle. We'll have to come up with something. I've never done anything like that before. Yeah, like Saturn. Something looks weird. Band 1 is the low part, so that should be the quietest part. So why does that one look like it's the one multiplied by 2.5? Crusher 1, prepare, set mult 1. Band 1 mix. Oh, I'm still doing this. Yeah, okay. I made this test with a with just some simple wave shaping, and that's what's messing it up. So I need to, let's see. Yeah, what I need to do is just do this. Yeah, I just need to add these together. Okay, we're not gonna have a mix, but it is gonna show up, so we should be able to still see it. What we might have to do, since this might have a bunch of parameters, is make the Bit Crusher kind of like one knob or two knob or something, because we're gonna have too many parameters. Okay, this still isn't looking the way I thought it would. It's backwards from what I thought. Or did I? Yeah, of course. That's what I did. Look, I didn't actually. Yeah, so just the first one was being multiplied by 2.5, and then nothing else changed. Classic. Okay, there we go. Yeah, that looks correct. Okay. Great. So we know that is working. So I guess we can start on the actual Bit Crusher. So let's get rid of this. That. Get rid of this. Just make sure it builds real quick. Yeah, it was supposed to look like a high shelf more. Oh, also, let me make this larger. Okay. Built? Okay, good. So we can just start on the Bit Crusher. So I've already made a Bit Crusher, so I'm just gonna take the DSP from that and then kind of, there's all kind of extra stuff that I did in it, so we'll just strip it down to like the basic and then kind of build up from there. So let's go grab this from Marauder Mac. So DSP, Bit Crusher. Okay, it's in the CPP file, I guess. Yeah, here we go. Oh yeah, I remember I added this half-wave rectifier thing in there to make it sound even weirder. So we can just take this and go through it and make sure that it works. All right, so I guess let me bring this down a little bit. So we're gonna have to return this for one. Okay, and we're gonna get some errors on names. So let's see, I have mix, get next value. Okay. And let's see. I've got this pink noise thing in there, so let's comment that out because I think we're gonna do that eventually, but val is equal to data. Why isn't it dry? Yeah, I'm already thinking this looks weird. I have a dry, let's see, I'm gonna rename that. And then let's make a wet signal. Okay, so that val, which I guess is gonna be wet signal. And then I think we can ignore this part for now. We're going to need a bit depth parameter. So let's do wet signal again right here. Let's see. Wet signal minus equals, and then what is sample? Okay, so maybe, okay. I think maybe I don't want to use oh, wait. So this kind of has to be based on using a like a loop instead of what's it called, sample by sample. Let me grab my book real quick. I've got the Hack Audio book. And I'm pretty sure this came from that. Oh, actually, it looks very different. Okay. Okay, I think we can still get away with this, doing it sample by sample, because this is way simpler than what I have here. So let's see, let's start here. Okay, that looks correct. So let's make a bit depth variable before we go too far. So let's see. So bit depth, and then we're gonna go into here. Let's see. Current. So let's do 16 is where it's gonna start at, I guess. And then we're gonna make a okay. We didn't make any setters yet, but that's okay. We'll do that in a second. So let's see. Bit Crusher. Okay. So this part looks correct. We've got 2 raised to the number of bit depth levels. So I guess we're gonna do like 8 to 16 or 8 to 24. See whatever sounds good. So that part's correct. And then we need to apparently shrink the full scale signal to fit within the range of 0 to 1. So we'll do that. We'll say, yeah, so let's keep that. And we'll say wet level or wet signal is, let's see, yeah, equal to 0.5 times your input plus 0.5. Let's see, is that gonna work? Yeah, and then we scale it again to fit within the range of possible values. So we'll do this again where we'll say wet signal is equal to your total Q values. Yeah, times that input. So hopefully this works out. And then you round it, which is gonna give you that bit depth kind of, or that bit crusher kind of sound. So yeah. So we'll make a new signal apparently. Auto actually, we don't have to do that. We could just say wet signal is equal to let's see, std round wet signal, and then that would be divided by total Q levels and then I'll just do it in the same line, but next we're going to put it back into the scale that we need. So this will be times 2. I know I don't have to put parentheses here, but it makes me feel better. And then minus 1. And let's leave it like that and just build it and check it out in Plugin Doctor. So we are going to, I guess, comment all this stuff out. And let's set the bit depth to something that should sound like it's working. So like 10. Yeah, let's see what happens. Oh, it's probably the, let's see. Oh, yeah, input. Oh, there's another thing we should do to make sure this is working. Let's just see what it does first, and then I'll make some changes. Oh, it might be working. Because that certainly looks weird. Although the oscilloscope doesn't look weird. Maybe it's because of the frequency. So let's try this. Let's go back to the plugin, and we'll instead of doing the multi-band logic, let's just do a simple buffer loop, and just kind of monitor the bit crusher on the full signal so that we can know that it's working. Well, that's weird. Let's see. Buffer crusher 1 process sample. So crusher 1 process sample turn. What if we do 6? Why doesn't it look weird? Okay, there we go. Yeah, I can tell. You can tell that it's bit crushed because of all the little flat plateaus. Okay, so let's add in some parameters so that we can actually change the bit depth. So we're going to need to add some kind of setter for the bit depth. That ought to do it. So 24, and we'll need to add that to the plugin. So we'll go to parameters, globals. Let's see. You can actually leave the extern keyword in here. I've been erasing it, but it doesn't matter. I know this is the boring part. And yep. So let's see. Something that has a range already. Oh, I guess they all already have a normalizable range. Okay, so let me just do this. Just grab this one, put it here. And let's see, bit depth 1, bit depth 1 name, and then a normalizable range. Yeah. This is gonna be, I'm not even sure. Let's say 2 to 24. And it'll move by whole numbers. And it'll start at 24, I guess. And then in here, update parameter crusher1 dot set bit depth. All right, let's see if we have any build errors. Yeah, so it's going to be multi-band, so 4 bands, and you can do bit crushing, and I'm going to see what other cool stuff we can add to it to be like a good sound design kind of thing. I'm thinking about adding a like CarPlus Strong string model to give it like a weird reverberation that sounds like delay. The problem is we're going to need 4 bit crushers, 1 for each band, so we're going to have a bunch of parameters. So we're either going to have to really design the GUI well or make it more of like a one knob thing for each band. Let's go, yep, okay. And I have a bit depth now. There we go. So it doesn't make a huge difference until six. So let's skew that so that 6 is in the middle. So what we're gonna do is make a bit depth range, which is gonna be equal to this. And then we're gonna say bit depth range dot set skew for center, and then you could put what value you want in the center, and it should skew it for you. Maybe we should put something even lower. And we should be able to do this and build it. If you ever see me typing really slow, it's because I'm tapping my hand with the rhythm of the bass drum in the beat, and I get caught up doing that. All right, bit depth. Oh, not even looking at the right thing. Oh wait, let's see what it looks like. It's just some kind of plugin doctor artifact. All right, oscilloscope. Yeah, there we go. I guess we can go to 1. Let's see what 1 looks like. And let's check it out in Logic, because it doesn't look like it's exploding or anything like that. Let's just make sure that change didn't destroy it. Marauder. Alright, oscilloscope. Okay, yeah, it should be okay. And I wonder if we should, we can probably make the bit depth not a whole number. Let's see what it does. Because it's rounding anyway, so it should be okay. Oh, that's weird. Oh, I bet if we make it by 0.5, it'll be okay. Because maybe the rounding is getting in the way. Oh, yeah. It's probably better if we just stick to 1. Yeah. Alright, let's check it out on Logic. Yeah, I did whole numbers first, but I was just experimenting with decimal places. But I'm going to put it back to 1. All right, let's see. Is the audio coming through? It's a good idea. That's pretty cool already. I don't understand why it's still moving by 0.5 though. Well, let's save and redo it. Oh, I put on the wrong one. All right, so that is good. So let's see. It seems like it's working. Next thing that needs to happen is there needs to be a resample. So the other part of bit crushing is not just changing the bit depth, but also changing the sample rate, like lowering the sample rate. And I kind of forgot how to do that. If we pull up Marauder, okay, so which one? It must be this. I think rate divide. Let's see, what's rate divide? Yeah, it's rate divide. So that's the other part we need. And we need access to the previous sample. Okay, let's see. Let's just copy and paste this. All right, where would that be? Let's see, we got total Q levels. Is that, and then remainder. We don't have the remainder thing. Not sure where it should go. That, like that. Okay. And then val. Let's see. This is equal to, or actually we can just say minus equals remainder. Okay, and let's see. We also need this. In fact, I'm not, we don't have a rate divide yet, so let's just make it right here, even though it's not going to do anything, just so that we don't see errors. So rate divide, and then if wet signal, oh wait, no, this is sample, so this is the current index that we're on. Okay, so we gotta pass it sample. So it should be good. Sample, sample, sample. And then we'll say wet signal is equal to, we need the previous sample. I wonder if there's a different way we can, let's see. Let's see, let's just make something called float previous sample and not set it to anything, and then we'll say previous sample is equal to maybe wet signal, right? So we'll put that right before the return statement. And now we can, let's see. I wonder, the problem is this has to be a process sample, like a sample by sample loop. So how do I make this work? I'm not sure. Let's just do this. It's not correct, but maybe it'll do something cool. And then I think we should set something. Oh, or we could do this. If rate divide is greater than 1 and sample is greater than 0. So that we skip the first one. And what does rate divide need to be in the range of? Here we go. Get resampled rate temp value 0, 51 to 0. So 25 is the middle. So what's bitrate range? Bitrate range, okay. Sample rate, set mix, pink noise. Where's this bitrate range? Ah, I see. Oh, I kind of remember this. All right. Let's see. Okay. That, like that. And let's see, what was the other part we need? This, let's see. We'll make this 25 because that's in the center of the range that was already set. And then let's make this parameter. So we're gonna say, I'm gonna call it resample. And we're gonna add it here. And I don't remember what the range needs to be, so rate divised equal to bit range. Yeah, okay, so we're gonna say this is gonna be set target. Yeah, we could add a randomizer, definitely. That would give it something interesting. I'm gonna put this in here just to make sure that it actually works. Okay, that, and then we're gonna replace oh wait. All right, well, I'm just gonna copy this line here. And then we're gonna go back into the audio part and we're gonna replace rate divide this get next value. Hopefully that, yep, that popped up. So resample, resample, and resample. Get rid of that. And all right, this might do something. It might not. All right. Oh, val. Remainder is okay. That maybe. I don't, now that I think about it, I don't remember where I got this from because it's not in the book. Oh, what was that? I'm saying previous sample. Oh, you know what? Previous sample might need to be an int and actually just get the index. So int previous sample, and then previous sample is equal to sample, and then now does that work? Oh, let's see what we got here. Sample. Oh, we're not even using this, but it's gonna complain. In fact, I'm just gonna comment it out. All right, this might be wild because I know it's not 100% correct. Hmm. I feel like it should be doing something else. Oh, well, that looks weird, so maybe, let's see. Okay, maybe we can't check it that way. We probably need to go through making the actual parameter so that we can actually try it out. And if I remember correctly, this parameter needs to be rate divide, which does that come in here? Resampled rate. Resampled rate is equal to parameter. Okay. Let me actually open this so that it's a little easier. Yeah, so where is this resampled rate used? Wait, where? It's not even being used by anything. Resampled rate. Set resampled rate. Resampled rate. Set resampled rate. Rate divide. Okay. So apparently, interesting. Okay, so we need to set resampled rate. It takes in a value. which is this long expression. So we could probably just boil this down to okay, let's see. So let's go to Bit Crusher, set bit depth. Okay. So take this. Oh yeah, I remember. Oh, the whole point of this was to reverse the range. Okay. That, and then we'll go right here. And it is not rate divide anymore. It is resample, set target value to this. Okay. And we have our current sample rate. So in here we said set resampled rate and then resampled rate. All right, so this might be a little different, so we might have to see. Because now I'm thinking that current sample rate. Okay, but then resample needs to be from the plugin. So let's see. Where's my parameter layout? No telling on something this old. Parameter change, and then here we go, resample. From 100 to 44.1. Okay. So now, is this messed up? Yeah, I think I need to go back and make that rate divide thing. So we'll say float rate divide. Right. Yeah. And we put that here. Okay, and then we need to actually make, let's see. Oh, wait. Oh, I'm confusing myself because this says, let's see, set resample rate, and it takes in a value, but I don't see, oh, there's value. Okay. Value goes there. Okay. So that means new resampled rate goes here. So how does... Oh. So, okay, so we give it the resampled rate right here. So I guess we need to set, let's see, set... I guess we need to make another one that has a different name. I don't know, set raw. Or actually, this is what we'll do. This one will be private. And this one will be set resample rate. Oh, we could say resampled rate. That's good enough. So what we'll do is say resample dot set target value, and that will be this. And now this is going to be set, and yeah. So do I need to change any of this stuff? Because let's see, when I call this, it's resampled rate, and resampled rate is starting at 44.1. Okay, so let's go to hours and say resample. Sure, starts at 44.100. And that might be good enough. I'm not sure. Let's go make the parameters for resampled. Okay, so we'll say resample rate and resample rate. Name, and then this is going to be this is going to be, I think, 100 to 44.1, and it moves by 1, and it'll start at 44.1, and we need to actually do this. All right, I have no idea if this is going to do anything. Oh, we're also gonna need to skew that one too, actually, because we want the dial to seem smooth. When it's just like 0 to 44, it'll seem like it's offset by a lot. What's the use of current resample rate? Yes, current sample rate. Yes. Okay, build succeeded. Well, it certainly doesn't look like it's doing anything weird yet. Yeah. Okay, so let's do a couple things. Let's make sure we're actually getting something from there. So let's go here, and I'm gonna take this. Let's say debug. Okay, right there. Okay, so we're getting it there. So let's make sure that in Bit Crusher we're getting, let's see, where is it? Let's see here. This should be resample Let's do it there. Set resample rate. Set. Oh. All right, looks like it's working now. Okay. Clamp value. If you hit this assertion, either your normalization function is not working correctly or your input is out of the expected bounds. Okay. So, what are the expected bounds? This does look kind of funny to me. I don't know what the point of this is. let's see, resampled rate. Current sample rate. Resampled rate again. Plus, yeah, okay, so what's wrong with that? And then we got yeah, resample rate is just equal to 100 to 44,001. Current sample rate value, set resampled rate is value. Okay, so what happens if I just put what happens if we do that? That certainly looks weird. Okay, but it's not really changing, so that's not good. I know it causes that assert, but I don't know if it matters. Yeah, it's not really doing anything. So when I call set resampled rate, resample is equal to this. And resample gets used in, let's see, it gets used here. I guess I could try it in Logic and see if I hear anything. Yeah, it's not doing anything. I guess that could just be the stuff that I did in here is not doing anything. Actually, let's do that. And previous sample equals 0. Rate divide. Sure. Well, I must just be doing that part incorrectly right here. Let's see, let me look at this one last time. I'm gonna put it back to where it was, and then I might have to do some research before I can finish this resample part. So amp values, how to blah blah blah. Okay, so apparently, let's see, let's get rid of this. Get rid of this. Yep. I just want to make sure it's back to working. I really want to have the resample part in here, so I'm definitely not going to give up on it. Let's see, bit depth still works. Yep, okay. All right, well, the bit depth works, so we'll have to figure out the resample part, and then we can probably do some cool filtering in here to kind of affect the way the bit depth and the, well, not the bit depth, but the resample definitely works and behaves. So yeah, I'll try to do some research for Thursday and figure this out. But yeah, I think I'm gonna head off for tonight. Thanks for watching, everyone. I'll be back on Thursday, probably same time, probably 5 p.m. my time, so that's Central Standard Time. Yeah, so if you're not in the Discord, please go join it. We'd love to have you there. And thanks for watching. I'll see y'all next time. Later.